Hello, so today we are doing this Leetcode medium problem called product array except self, problem 238. And the problem says given an array nums of n integers such that n is bigger than 1, which means basically that the array is not empty and contains more than one element, when I return an array output such that the output as position I is equal to the product of all the elements of the array except the number itself, except nums of I, right? And as an example here, we have this 1, 2, 3, 4 array, and you can see the first element is 2 multiplied by 3, which is 6 multiplied by 4, which is 24. The position here is 3 multiplied by 4, so multiplied by 1, so everything except 2, which gives us 12. Here, the position here is everything except 3, and so this is 2 multiplied by 4, that's 8. And for this 4, everything in the array except 4, so these 3 here, so 3 multiplied by 2, 6 multiplied by 1, that's 6. And so that's the problem. And a note here which says that we should solve it without using division. And here a follow-up that we should use constant space. So let's see how we can, so why did they leave this note here without division? Because if we use division, we could just like first compute the entire product, and so end up with 24, and then for this one divide by 1 we get 24, and then for this one we divide by 2 get 12, but that would be too easy, and so the note here says to not use division. So now let's see how we can okay, so let's see how we can solve this problem. So the example that we have here in the problem description is we have this array 1, 2, 3, 4, and as we said, we can't. If we could use division, then we would just compute the entire product, which is 24, and we would, for the first one, we would just divide it by 1, so we would get 24. For 2, divided by 2, so because it's the product except the number, so that would give us 12. Divide here by 3. That would give us 8, divide here by 4, that would give us 6. And so this is what we would do if we could use division, but we can't. So how can we solve this in a way that is in oven way, basically, as the problem describes? So one thing we can do is, well, what we want is everything except the element itself, right? So what we can is, if we know so essentially what is the product except self, right? So it's just the product of the left side excluding, of course, the element, multiplied by product of the right side, right? So essentially, if we take this 1, 2, 3, 4 for the element 2, or let's say for the element 3, maybe I would just add another element. Let's say we have this something like this, maybe 6. So the product for 2 is just the product let's say for 3 except self at the position. So this is 0, 1, 2, 3, 4. So for position 2 in the final array, the product is just this portion here multiplied by this portion, right? And if we do another one, let's say for the same array for position 4, this position here, we have 0, 1, 2, 3, 4. So the product is the product of the left side multiplied by the product of the right side, right? So every point is just everything left of it, the product of everything left to it multiplied by everything right of it, right? So we could just compute separately both things, the left portion and the right portion. So compute product left, or left product, let's call it. So this would be the first step, left product for all positions in the array, right? So that would be, of course, an O(n) operation, right? So this would be O(n), and then we would do the same thing, which is compute, except this time right product Same thing for all positions in the array, right? And that would be also O of n. And now to get the output array, just for every I, we could just say the result at that position would be just the left portion, everything left of that position, which would be computed already at the position I, multiplied by the right product, which is computed already also. And so this also, since we will do it for every I, it will be O of n. And so O of 3n, that's pretty much just O of n, and we get the solution without using division and in O of n time. And so how would that look like in terms of in code? So we would need to, so let's just define product here, except self. And so what we get initially is the array of numbers. And so what we need to do first is compute the left side, right? So let's say we have so we need to compute the left side. I won't fill in the details, we'll do that in Leetcode later, but we would first compute the left side. So we would initialize left product, but here we would do, for every position, what is the formula to compute the left product for position I. So since for the first position here, there is nothing left of it, so we will leave the product as just 1, right? So here, when we are initializing the left product here, we would say it's just 1. It's initialized to 1 for all the elements, which is just length of nums, and it would be just the previous. So if we are computing the left product, let's say we have here I minus 1, and then here I, right? So the we have already computed the left product for I minus 1. So for I, it would be just this multiplied by this. Remember, it's the left product means everything excluding I itself. So it would be just the left product for I minus 1, which is this portion here. So this is the left product for I minus 1. And then we'll multiply it by the element to the left of I, but not included in left product of I minus 1, which is just the number at I minus 1, right? So this is essentially what we will be doing here. So let's just write that out. So it would be left product for the previous position, which means this is basically would be from the start I minus 1, which would be from the start to position I minus 2. And so we will need to include I minus 1. So this range here, since we are doing I minus 1, we need to start out from 1, because if we start from 0, that's minus 1. And also for element at position 0, there is no left product. It's just 1, right? And so we keep it like that. And we do a similar thing for right product, so which would be 1 also, initialize it to 1. Same thing, range of length of numbers. And we would do here similar thing, where except it's we are starting from the right, because we are computing for each one for this position I here. We would be, so for I here, it would be this portion. It would be this portion, which is right product of I plus 1, and then we will need to multiply this new thing, which is to the left of I, which is I plus 1. But in order to have right product I plus 1 at position I, we need to have our loop goes backwards, right? Because if it goes forward, we would have I minus 1 and not I plus 1, like we did here. And so our loop will need to start out from range here. But also one thing we need to remember is that the last position here, n minus 1, it has no right product, so it's just 1. And so we don't need to do that one, so we need to start out from the position next to it. because that's where it starts having a right product, which is this n minus 1. So we need to start from n minus 2, and we need to keep decrementing because we are going backwards. And so we decrement by 1, and we stop when we reach 0. 0 has this entire portion of the array as its right product, right? This entire portion here, right? And so here we need to stop when we reach 0, so we put minus 1, and the right product would be at position I, at this point would be, as we said, right product at I plus 1 multiplied by number at I plus 1, right? So the right product, which basically means, just give myself some space here. So it would be so this would be the product from I plus 2 all the way till the end. So we need to multiply nims of I plus 1 because that's to the right of I. So now that we have both, for each element, to get the result, we just multiply its left side by its right side. And so, so the result here, we would just say for every element in the array that we are looking to get the problem says every position we need to get the product of the array except itself, and so we would do this, and our result would be just the left product at position I. So we would need to add it, so we need to append basically the left product at position I multiplied by the right product also at position I, and at the end we can just return res. So here you could see we did the steps that we mentioned here. So this is the first step to compute the left side, this is the second step to compute the right product, and this is the last step to compute the final result, and this is all in oven. So here in terms of time complexity, we are doing 3 for loops that are each oven, so it's like just oven. For the space complexity, we are using left product, right product, and res, and all of them have n, so it's of 3n, so it's just oven in terms of space. So let's type this in Leetcode and make sure it passes. Okay, so I typed the solution that we just saw in the overview here. It's the exact same solution, so let's run it and see if it passes. Okay, so it passes test cases. Okay, so now one thing the problem says is that, as a follow-up, is that can you solve it with constant space complexity, which means that, but the output array with the result itself doesn't count as extra space. And so how can we do that? So basically, essentially what this means is that we need to get rid of these 2 arrays for left product and right product. And res, they don't mind using it, it seems. So let's see how can we do that. So one thing you can notice actually is, well, right product, we can just compute it with a variable. We don't need an array. Why is that? Because at any point, once we have the left side, we just need to multiply the position by its right side product, and we would get the result, right? And so, and we can just keep variable that accumulates the right product as we move backwards, and we can multiply that by whatever it is in the left product. And the left product, we can just rename that to res, and at that point we no longer need res here. And since we will do the multiplication while doing the multiplication for the right product, we can get rid of this. And this here we will do with just a variable, so we need just res, right, and initialize it to 1. And so here, instead of this, we would have right, which is just right multiplied by. So instead of doing I plus 1, the value that was at I plus 1, that is now stored in right. And so we could just multiply right here. There is just one thing here, which is now what I will be doing, instead of nums plus I will be doing this for the next iteration, right? For the current iteration, the res at position I, which has the left product, the left of I, the product of the left of I need to multiply the right product, which is whatever is in the variable right now, right? So that would be just this multiplied by right. But here, I shouldn't multiply by I plus 1 here. I should multiply by I. Why is that? Because the update I'm doing here, I'm doing it for the next I, not for the current I. So for the next I, which is the I minus 1, that one, it's its right product is everything from this I, the current I. Basically, the right product for the next I is everything in the current I all the way to the end. And so I need to multiply just I. And then one other change I need to make is that I need to do n minus 1. Why is that? Because if I keep n minus 2, then the right value for n minus 2 would be 1, which is wrong. The right value for n minus 2 should be n minus 1, should be the value at n minus 1. And so to get that to happen with this computation here, I would do minus 1. And for res of n minus 1, nothing will change because I will be multiplying just by 1, which doesn't change anything. And that's all the change we need to do. And I just need to remove this. We don't no longer need this right product. And the left product just became res. So let's just use that. And that's pretty much it. So let's run this. And also, just to make this a little bit more convention, I'll just multiply it this way. Okay, so let's submit. Okay, so that passes the test cases. And in terms of time complexity, the time complexity for this one is still the same, right? Because we haven't changed anything. So we still have, even though we got rid of one for loop, we still have 2 for loops, so it's still O of n. Space complexity still O of n, but we are just not using, because of this result array, but we are not doing extra space as in the way they define it here. Yeah, so that's pretty much it for this problem. Thanks for watching and see you next time.